All right, here we go. Let's do another example. Which one was this? 5? Yeah. Okay, cool. All right. How about, and we'll write it a little different so you guys can see it a different way. How about we do 30 is equal to negative, I don't know, 6 minus 5 over 6 times x. Okay. Now, what is not fun about this problem? The fraction, right? So that 6 in the bottom of the fraction, if I can move that away, then I would end up with a whole number, and that makes it a little easier, right? Now, we might have a fraction as the answer. Now, one way you could solve this problem is we got to find a common denominator of all 3 of those numbers at some point. That's no fun. So what I'm going to do is, what is this 6 doing to the x? It's dividing. Yeah, sometimes you guys blurt out what we're supposed to do, and that's okay too. So technically, it's dividing x by 6. So to get rid of it, we do the inverse, right? So our goal always is to get x by itself and all the other stuff on the other side. And how do we do that, guys? We do the inverse, right? We do the inverse. Inverse is a fancy math word. It means opposite. They'll probably talk about multiplicative and additive inverses on the SAT, so that's why I'm talking about it with you guys now. Okay. Most of you guys will use the term opposite. Anyways, so if I multiply everything by 6, because remember, I'm going to multiply by 6 to kind of fix this thing. What I want to point out to you guys, though, so when I multiply this by this, I'm multiplying it by this term, and you have to include the sign in front of the term. So really what I'm doing mathematically is I'm multiplying negative 5 over 6 times x. Now when I do that, and let's do this over here to the side, really what I'm saying is negative 5 over 6 times 6 over 1. What is negative 5 times 6? Negative 30. What is negative 30 over 6 reduced down to? Negative 5. Now, what's interesting about this, when I multiply a fraction by the denominator of the fraction, we end up with just the numerator. We end up with just the numerator because what is 6 divided by 6? You know what I'm saying? What is 6 divided by 6? This is equal to 1. So really, we're left with the numerator times 1. So we did all that math to get negative 5x. Right? We got to tack on the x. We can't just get rid of it or ignore it. All right. So now let's do that again. We're going to multiply 6 by what over here? Negative 6. What's negative 6 times 6? Negative 36. Okay. And that is equal to, we're not done. We got to multiply 6 times 30. What's 6 times 30? 180. Holy moly. All right, cool. So now remember, our goal is to get x by itself and all the other stuff on the other side. So I got to move the negative 36 or the negative 5. Remember, that coefficient that's in front of the x, almost always the last one. That's the last thing we do. So I'm going to move the negative 36. What is minus 36 doing to the x term? Yeah, it's subtracting, and so we have to do the inverse, which is to add. So we're going to add 36. And whatever we do on one side, we have to do to the other. So we end up with, what's 36 minus 36? 0. What's 0 plus negative 5x? Negative 5x. Now over here, I've got to add 180 plus 6. So 0 plus 6 is 6. 8 plus 3 is 11. Write down the 1, carry the 1. 1 plus 1 is 2. 216. I heard a lot of people say 216. That's right. Now I'm going to get rid of the negative 5. Now technically, negative 5x is the same as negative 5 times x. What's the inverse of multiplying? Dividing. Don't forget the negative sign. Don't forget it. Whatever you do on one side, you got to do on the other. Now, you can't really reduce this fraction because 5 only divides evenly into, the last digit has to be a 0 or a 5. And since the last digit of this number is 6, it doesn't divide evenly into it. So as weird as the answer looks, it's right. That makes sense? Doesn't make sense? What part doesn't make sense? Yeah, because usually, so in Algebra 1, the problems are kind of rigged up so you get like x equals 3, or x equals 3/4, or x equals 1/2. Like even if it's a fraction, it seems regular. If you see a problem like this, you probably should double check your work to make sure it's right? But in Algebra 2, you do have problems that look like this. So when I say it looks wrong, but it's right, what I mean by that is, that's the type of problems those are the types of answers you get sometimes. Yes, I have a question. No, so yeah, and that's the other thing too. In Algebra 2, we want to leave it as a fraction, okay? We want it to be a simplified version of the fraction, but we want to leave it as a fraction. So one of the things at some point in time, I'll share this with you guys. There's a thing called Symbol Lab. Have any of you guys used that? I think I misspelled it. It's a math solver, and you guys use them on your phone. I forget the app where you take a picture of the equation and it gives you the answer. So always double check. There's a couple ways. In fact, one way you could see if this is right or not is we'll do Desmos. So let me do it on Desmos. That's an easy way. Has anybody ever showed you that you can graph the left-hand side and graph the right-hand side of the equal sign, and where they cross is the answer? You guys ever seen that? Well, let me show you, and I'll leave it in the video so you know how to do it. So this equation is 30 equals all this other stuff, right? The original equation was 30 equals negative 6 minus 5 over 6x. So if I graph y equals 30, okay? And I've got to zoom out so I can see it. That's just a horizontal line at 30. And then I graph y equals, what was the right-hand side of the equal sign? Negative 6. Negative 6 minus 5 divided by 6 times x. Is that right? So I'm going to slow down. I'm going kind of fast. Do you see that this is the left-hand side of the equal sign right here? So I'm just saying y equals 30. And then for my second equation, I'm saying y equals negative 6 minus 5, 6x. See that? Now it's going to cross here. It crosses at negative 43.2. What do you think negative 216 divided by 5 is? Negative 43.2. Oh, I bet you thought that I was just some basic average math teacher. Do you think I came here to teach math? I'm not playing around. Does that make sense? So always double check your work. So what I was saying when I said like it looks wrong, but it's right. If you see something like that, it's possible you made a mistake, but there's a way that you could double check it. You could double check it on a calculator. You could plug it back in and see if it works. But there's always a way to double check it. And if you double check it and the answer you get works, then it's the right answer. If